Unlocking Click PLC and Machine Simulator integration, a game changer for industrial automation professionals. In increasing sophisticated industrial automation era, seamless integration between programmable logic controllers (PLC) and simulation tools is more critical than ever. Machine Simulator by Nartek is a sophisticated yet simple software for creating virtual simulations of industrial machinery and processes. It enables you to visualize and test your systems in a virtual environment before implementing them in the real world. Click PLCs have been a long staple for automation engineers, offering a reliable and user-friendly solution for various control processes. However, integrating Click PLCs with Machine Integrator unlocks a whole new level of potential. This post will explore the benefits and methodologies of unlocking Click PLCs and Machine Simulator integration. We will be using the Machine Simulator's test conveyor example. This practical example will utilize the Click PLC Modbus TCP communications to the simulator Modbus Server driver. Let's get started. Detailed information contained in this video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. What is Machine Simulator, EasyPLC? Machine Simulator by Nartek is sophisticated yet uncomplicated software that is part of a price-competitive machine simulator suite, EasyPLC. It can create virtual simulations of industrial machinery and processes, enabling engineers and automation professionals to visualize and test their systems in a virtual environment before implementing them in the real world. The latest Modbus Server driver lets you place the machine simulator scene on your network. Multiple devices such as PLCs and HMI can access and control the system. This contrasts traditional machine simulators which can only act as a Modbus client communicating with just one device. Machine Simulator by Nartek gives you the option. Machine Simulator Modbus Server, Automation Training Machine. We will use a pre-built scene in the Machine Simulator or MS. Start the Machine Simulator and select Machines icon on the top menu. You can also select Open Machine Start Simulation on the main page. All of the pre-built machines will now be displayed. They have been programmed so you can immediately start learning with this package. We will use the Zero First Test Conveyor example. Selections will be displayed as you move your mouse over the machine icon. Select the exclamation point in the upper right corner. This will display the machine description of what you need to program. The object is to move the pallet on the roller conveyor first to the right, PLC digital output 1, until the photosensor on the right activates the digital input 0 to the PLC. Then the rotation of the conveyor rollers is activated so the box moves to the left, PLC digital output 1, until the photocell on the left side is activated, PLC digital input 1. Then reverse the rotation of the rollers, repeating the process. Select Close. The demo mode will demonstrate how the machine functions. Select Start. The Machine Simulator will now load the conveyor example. In the bottom left corner you will see that we have no PLC connection. Select I/O drivers on the top menu. Under the driver name you will see that this EasyPLC is selected by default. Select EasyPLC to call up the Machine Simulator drivers. Select Modbus Server driver. The Modbus Server driver uses TCP/IP protocol on Ethernet to communicate with other Modbus devices and software. Select the Configure button. We can now assign the Machine Simulator's digital inputs and outputs to the two different Modbus memory areas. In our case, the PLC's coil outputs will be MS digital inputs. The PLC digital inputs will be MS digital outputs. Although our machine does not use any analog inputs, we can still set this up. Modbus PLC holding registers will be used as analog inputs, and the PLC analog input registers will be the MS analog outputs. The machine simulator uses analog scaling and subtraction factors to represent negative numbers since Modbus analog is a 16-bit word. Select OK. Our PLC inputs and outputs are now displayed. We can assign the inputs and outputs to our machine simulator I/O. This can be done by clicking and dragging the PLC input to the machine simulator input and the PLC output to the machine simulator output. However, you can select Automatic Assignment from the driver menu. This will automatically assign the inputs and outputs in the order they appear, saving you time. Select Automatic Assignment. Under the Exit menu, select Start Driver and Exit. Our test conveyor example is now ready for communication. The green Driver Connected indicated on the bottom of the screen indicates this. Select View I/O to show the MS's inputs and output status. Since this is a Modbus server setup, we can use multiple Modbus clients to communicate to our machine simulator. IP address of machine simulator. The IP address of our MS conveyor example will be the IP address of the local computer running the software. If you are unsure, start a command prompt on your Windows computer. Type the command ipconfig /all and press enter. You will now see the IP address listed. We will need this information to configure the Modbus client device, which in our case is the Click PLC. The realistic simulations environment is now on the network as a Modbus TCP Ethernet server. We can now test or create multiple control programs for our selected simulation scene. Integrating with multiple PLCs or programmable logic controllers, including the Click PLC, is easy, as the PLC now acts as the Modbus client. This cost-effective training tool reduces the costs and risks of working on physical machines. What is Click PLC? Click PLC is a compact and affordable controller designed by Coil Electronics and sold through its subsidiary Automation Direct. It is ideal for small to medium-sized automation projects. Its intuitive design, rich features such as high-speed counting, and variety of I/O make it a favorite among many engineers. However, the need for integration simulation tool becomes apparent as projects become increasingly complex. Integrating Click PLC with a machine simulator creates a robust testing environment. Engineers can simulate process flow, monitor system behaviors, and troubleshoot potential issues in a virtual setting before deploying actual systems. This can significantly reduce the time and cost associated with the on-site troubleshooting. Setting up the Click PLC configuration and communication ports. We can install and start this package on our computer using the free Click PLC programming software. The entire Click PLC series can be found here. Once the Click programming software starts, you will see the startup window. Select Start a new project. The Select a CPU module window will now be displayed. Scroll down and select the CPU that we will be programming. Select C2-03 CPU for our Click PLC that we will program and select OK. The User Account Setup window will appear. Select Disable Password Requirement and then press OK. We can select System Configuration on the Home tab under CPU or on the Function tab of the navigation window under CPU Configuration. The System Configuration allows us to specify the inputs and output PLC cards we have or will install. When the System Configuration window is displayed, it shows a picture of the CPU and the current system I/O. The software will determine the power available and required for configuring the Click PLC as part of the configuration. This is located under Power Budget. Under the Power Supply PS, select the CO-01 AC unit. This will provide 1,300 milliamps of power, which is more than enough for anything we can install on the PLC. Select OK. Under slot 0, select the Select button. We will add the C0-08DR-4VC card for the slot on the CPU. Select Module Configuration. The Click PLC has automatic scaling for the analog input and output points. Enter the data register DF1 to automatically set these registers. Select OK. Selecting OK again will bring us back to the system configuration window where we can now see our Click PLC and the addresses assigned. At the top of the window we can name this PLC. Enter a name and select OK. The name will appear on the network indicating which PLC we want to communicate with using the Click programming software. We can now examine the communication port settings on our Click PLC. While still on the Function tab of the navigation window, we can select COM Port 1 Setup. The COM Port Setup Details window will now be displayed. Under the port setting, we can choose all the different ports available on this PLC model. Port 1 is our Ethernet port settings. This port's wiring and system addresses can be seen in the middle and right side of the window. We will set a static IP address for port 1 and ensure its location on our network. We will also set the DNS server addresses for the Ethernet port. Select OK. Under the CPU selection on the Home tab, we will select the Modbus TCP setup. This will show the Modbus client and server enables and default selections. We will leave everything as our default and select OK. Let's also set up the wireless port setting on our Click PLC. Under the CPU on the Home tab, select Wireless Port Setup. Once again, our COM Port Setup Details window will be displayed. We can enable the wireless LAN and assign a static IP address and DNS server locations to the port. The SSID and password for the existing wireless network must be entered. Select OK. We can now save our program with a unique name. We are now ready to begin programming our communication to the machine simulator. Click PLC Modbus TCP Client Subroutine. A separate subroutine will handle the Modbus TCP client communication to the machine simulator conveyor example. To start a new subroutine, right-click on the subroutine program under the Program tab of the navigation window. Then select Add New Subroutine Program or Ctrl-U. We can now enter the name of this new subroutine. Select OK. Our new subroutine appears on the Subroutine Program heading in the navigation window. A subroutine quick guide is displayed. Select OK. Our communication subroutine will have a send and receive instruction on the leading and trailing edges of the 100 millisecond contact bit. The send command will be Modbus out of port 1. Enter the server or slave IP address that we obtained previously. We will leave the server port number as the default 502 and use the slave ID 1. The Modbus function code will be 15 to write multiple coils. Our addressing will be Modbus 984 and the starting slave address will be 1. C1 will be the starting master address and we will send 3 bits of information. The status flags will be set for internal bits to use later in our program. Select OK. The receive command will be the Modbus out of port 1. Enter the server or slave IP address that we obtained previously. We will leave the server port number as the default 502 and use the slave ID 1. The Modbus function code will be 02 to read the input status. Our addressing will be Modbus 984 and the starting slave address will be 100001. C101 will be the starting master address and we will read 3 bits of information. The status flags will be set for internal bits to use later in our program. Select OK. Insert a rung at the beginning of the subroutine. When the first bit, SC2, is turned on, we will set internal bit C1899 to indicate that communication reset is required. This will also turn off our internal communication bit C1900. Rung 2 will have a negative communication bit and not the sending bits for both send and receive instruction. This will also have the leading edge of the 100 millisecond clock bit flag in series to reset the communication reset bit and set the communication bit. Using the address picker under the Program tab of the navigation window, we can document all the internal bits we are using in the program. Rung 5 will add a communication timeout circuit. If the receive success bit is not turned on in 1 second, a timer expires and an output Y1 will be turned on. This will indicate that communications have been lost. Rung 6 will set the output after the timer expires. Rung 7 will reset the output on the receiving success bit's leading edge. Use the address picker to document the timers and output. Rung 8 will have the return. This marks the end of the program for the subroutine. Returning to the main program of the navigation window, we can use the first rung to call up the communication subroutine. Save the program. On the Home tab, select the Connect button. In the Connect to Click PLC window, select our PLC and choose Connect. Select Don't read the project from the PLC and select OK. On the Home tab, select Write Project. This will compile the program in the Click programming software and then transfer it to the PLC. Once the Click PLC program is transferred, we can put the PLC in run mode. Our communication is now working. From the navigation window, call up the Data View window. Enter the inputs and outputs for the Machine Simulator conveyor example. Returning to the Machine Simulator, we can now change the outputs in the Data View window and watch the conveyor function. We can now move on to creating the logic for our conveyor. If you are enjoying this video, please hit the like button below. Keeping up with the latest automation innovations can be difficult, so hit the subscribe button. Remember to click the bell beside your subscription to actually receive those notifications. Click PLC control logic for conveyor example. We will write the ladder logic program to control the conveyor example using the 5 steps for developing a PLC program. Since this is a simple circuit, we have 2 inputs and outputs from our machine simulator. The Modbus TCP communication from the outputs is C1 and C2. The inputs are C101 and C102. Using the description from the conveyor example in the machine simulator, we know the sequence of operation. The last steps are writing and testing the logic. Under the call to the subroutine, we will insert a couple rungs on the main program. When neither output is on, we will set C1 and reset C2, moving the box to the right. The next rung will have C1 on, and when the right sensor turns on, we will reset C1 and C2, sending the box to the left. Returning to the previous rung, when C2 is on and sensor C102 comes on, we will also set C1 and reset C2. Using the address picker, we can document the inputs and outputs. Save and transfer the program. Testing and operation of the system. We can now call up the data view window like before and watch our program in action on the conveyor example. Machine Simulator allows us to conduct extensive testing of our system. We can evaluate the performance of our PLC in the simulated environment, identifying any discrepancies, and rewrite the logic as needed to refine both the PLC program and the simulation model. Unlock the integration between Click PLC and Machine Simulators presents many benefits for automation professionals. Integration enhances testing environments, improves design validation, provides real-time monitoring, and facilitates training, enabling engineers to create safer, more efficient systems. Overall, Nartech's Machine Simulator is an invaluable tool for optimizing automation processes, enhancing training, and ensuring system reliability through effective design, validation, and testing. To learn more about Machine Simulator and how to create the ultimate machine learning package, click here. Click here to see the entire Machine Simulator series.